Okay, I am going to go ahead and show you how to do this, except for I'm stupid. I need to get to Notability. First of all, I can hear you guys yelling in the background, so you can hear yourselves. And I don't think there will be any barking in this video, but there's probably going to be a lot of screaming children. Okay, so key phrase, show your work. And I'm supposed to find average rate of change. Keep in mind that average is the one that's going to be using the slope formula, telling me that this is the first x and this is the second x, but I don't have any y's. So I'm going to go ahead and figure out what they are the old way that I've used since Algebra 1, and I'm going to plug in those numbers. Got my trusty calculator along because sometimes my brain fails me. That one's pretty easy. That turns out to be -3 because all these wipe out. Here I'm going to have -4 and then 2 squared, 16 times 2. Okay, so let's see here. I'm going to do a little mathing. And I got 13. I'm checking what I typed into the calculator because sometimes I make mistakes. Okay, so then that's a 13. So now I need to do average rate of change, which is going to be my slope formula. So it's 13y2 minus y1 over x2 minus x1. This turns into addition, so I get 16 over 2, which is otherwise known as 8 in big people math. All right. This is asking me to find the derivative. Since this is a polynomial up here, I can just use my power rule. So 2 times -4 becomes -8. The power goes down by 1, so it becomes 8 to the first instead of 8 to the second. In this term, there's a 1 power, so it multiplies by the 16. The x used to be to the 1 power, now it's to the none power, so it's gone. And constants, when you take their derivative, they disappear. So the derivative that I'm going to be using, you don't have to rewrite it, I'm just writing it so I can highlight it and remember where it is later. This is going to be my derivative if I need it in the future, which I will. In fact, here's the future. I need this. Instantaneous rate of change is different than average because this one's using your slope formula. This is where I actually, and notice it says show what you are doing. That means if you don't show what you're doing, you're not going to get all the points. And since it's your last hurrah, you want to get all the points. So I'm going to find the rate of change at whatever value is given, the instantaneous rate of change by plugging that number in to the derivative, not into the original. So I'm plugging it in here where there used to be an x, I'm putting in my 1, and I got 8. Now, be aware that the fact that these are both 8 is weird. It's not going to necessarily happen. So if you tomorrow get a different answer for instantaneous versus average, that is a-okay. In fact, it should happen that way more often than not. Okay, now I have to decide if it's increasing or decreasing at that value. Well, keep in mind that if you have a positive derivative, then it's increasing. If you have a negative derivative value, then it's decreasing. And if your derivative is equal to 0, then it's a max or a min. So all I'm doing is looking back at this answer and saying, okay, my derivative value at 1 is 8, don't care, but it's positive. And so that's going to tell me that it's increasing. So here it says, how do you know? You want to be able to write that the derivative's value at 1 equals a positive number. And so that leads me to believe that it is increasing. So just kind of explain that you know that in some form or fashion. Okay, keywords. Show how you find the derivative where the derivative is equal to 0. Well, again, keep in mind this was my derivative. So I'm showing how, and this is Algebra 1 every single time, how that equals 0. So I'm going to move that 16 over. I'm going to divide by -8, and I'm finding that it was equal 0 at x equals 2. So show how refers to this work, and then the question's actually asking, where is that going to equal 0? Because that's identifying either my max or min. So now I'm going to figure out where that is. It's kind of just leading you right through the process because the next part says, go ahead and make a sign chart. If you don't know what a sign chart is, you got to figure it out because I don't want you to ask me during the test because I'm going to say, you got to figure it out. And I'm going to feel bad. So since 2 was my 0, meaning that's where my derivative was 0, I'm going to toss down a 2. And then I'm going to test a point less than and greater than 2. It doesn't matter what number you pick. I'm going to plug it into the first derivative. That's why it's called the first derivative test. So I'm going to plug 0 into this derivative from up here. So I'd have negative 8 times 0 plus 16. I don't care that it's what the number is. I just care that it would be positive. Here, I'm finding the derivative's value at 3. So the derivative is going to be the negative 8 times 3 plus 16. Don't care what it is, only care that it's negative. So keep in mind that positive means it's increasing until you hit that value at 2, and then it's decreasing. So when that happens, the point where it changes around is a high point or a max, so I would just write max here. Now, this is what it's referring to when it says to create a sign chart. This is what I'd be looking to see for full credit. Then you can determine if it's a max or min based on that. And then lastly, on this front part, it's asking me to find where the coordinates are for that. And so the coordinates, I already know the x value because I found it earlier as the 0 up where? Here. But now I want the y value, and to get y values, you go back to the original function and you put that number in to the original function, not the derivative. So, oh, I already did that because that happens to be one of our points. That probably won't happen. When I do that, I'm going to still get out 13, just like I did before. That will not always happen. They won't always be the same. Okay. So on the back, just like this, tomorrow's quiz will ask you for the difference quotient. That's this thing. Liberty's class is cheering for me, I guess, because I finally made it to the back. I'm not sure. So I need to go ahead and do this, which means plug in x plus h everywhere there's an x. So I've got the 3, x plus h, and that's getting squared because of that, plus 2, and then x plus h, and then minus 1. That's plugging in the x plus h everywhere there is an x. Then I subtract the original function, which is this entire thing. And then I toss it all over h. And then you're going to need to FOIL, distribute, combine, cancel. So I'm going to start with the foiling, but this one is the one that I told you it's always going to turn out to be the same. X squared plus 2hx plus h squared. So this part is going to get replaced with that. Okay, so let's go ahead and distribute this 3. And now I'm to this, so I'm going to distribute that 2. And then I have this minus 1 hanging out. And then this negative is really easy to forget, but don't forget to distribute that. I'm still working on the top. Technically, it's all still over h, but I'm going to work at the top. So I did my foiling, I did my distributing. Now I'm going to kind of combine and cancel, and that all happens in one fell swoop. So this 3x squared cancels this negative 3x squared, which is good, because if you remember at this point, the ones without the h should cancel out. So I have a positive 2x and a negative 2x. I have a negative 1 and a positive 1. So the things I have left are here, here, and here, and they all have h. So I'm going to kind of combine 2 steps, and you can do this too on the test. I'm going to pull out the h as I bring those terms down. This will leave me with 6x. This one I'd just get rid of one of the h's, and this would leave me with just a plain 2. All over h, because that's what the formula tells us, is that there's an h on the bottom. Now those cancel. So my answer to this difference quotient is right here. Now I know sometimes we went back and plugged in a 0 for h, but we aren't doing that. We're not finding the final derivative. We're just finding the difference quotient. So we stop there. Leave the h if you get one. Okay, then this is the last thing, and this is the one that if you missed school the day of senior skip day, you have to be able to show that you know the product rule. It'll be on there just like this. This is the product rule, but you need to know how to use it. So you'll be given a product, one thing times another. So this is the U, and then this is the V. So I'm following this formula. To get the derivative, I'm going to take the first thing as is, check, times the derivative of this second part. So using my my polynomial like product, excuse me, power thing. 3 times 2 becomes 6x, power goes down by 1, and the 5 goes away because the derivative of a constant is nothing. Okay, then plus, and now here I'm going to be at u prime. So that's going to be the derivative of this guy. So 3 times 4 is 12, and the power goes down by 1. And then the end is this, v as is without any changes. So it's going to get multiplied by this original second part of my function. So then at this point, all I'm going to do is some math. I'm going to go ahead and multiply these. I'm going to make 24x to the 5th. Here, this has to distribute because I have 2 parts here. So I'm going to get a 24x to the 5th again, and 60x squared. So then my final answer is going to be that the derivative equals, and then these actually combine because they're both x to the 5th power. So I get 48x to the 5th plus 60x squared. See, they're cheering for me again. And this one's easy. It says, thank you for hanging in there with me for the year, for making my job fun, and for making school a place I love to be. Which is true. I have the greatest job on earth, and it's not because of the work or the grading or any of that. It's because of you guys. Peace out, sisters and brothers.